Hello guys, welcome back to Ayswarya's Math Classroom. Today we are starting chapter 2 of class 9 Mathematics Introduction to Linear Polynomials. In this video, we will build a strong foundation by understanding what algebraic expressions are through real life examples, and then we will learn how to classify polynomials by their degree. So let's get started. Chapter 2, Introduction to Linear Polynomials. Introduction. We have learned about algebraic expressions in earlier grades, right? In your previous grade, you have already studied what is algebraic expression. So in this chapter, we will learn about the special type of algebraic expression called linear polynomials. Let us first consider a few example of algebraic expressions. The first example. Raju went to a shop where there were sealed boxes of different colors on sale. The shop owner told him that the red boxes have 4 pens each and the blue boxes have 5 pencils each. Now, if Raju bought X red boxes and Y blue boxes, how can he quickly figure out the total quantities of pens and pencils? Also, if he got 3 extra pens free, how many pens and pencils did he get altogether? So here Raju goes to a stationery shop. The shopkeeper sells sealed red box containing 4 pens each. So here the red boxes contain 4 pens each, right? And blue box it contains 5 pencils each. Then Raju buys X number of red boxes. So the number of red boxes he buys is X and Y number of blue boxes. So number of blue boxes is equal to Y. Plus the shopkeeper gives him 3 extra free pens. So the number of pens he is getting is equal to 3. So here, how do we write an expression for the total quantity of pens and pencil Raju has? Observe that X red boxes will have 4X pens and Y blue boxes will have 5Y pencils. So the total pens from red boxes is equal to 4 into X, which is equal to 4X. And total pencils from blue boxes is equal to 5 into Y, which is equal to 5Y. Also, he got 3 extra free pens. So we can write free pens is equal to 3. So here, how can we write the algebraic expression? We'll get it as total quantity is equal to 4x plus 5y plus 3. So this is the algebraic expression we are getting. Okay, that is if one red box is having 4 pens, then x red boxes will have what? 4x pens, right? Similarly, if one blue box has 5 pencils, then Y blue box will have how many pencils? 5 pencils. And adding the 3 items, Raju gets a total algebraic expression of 4x plus 5y plus 3. In this example, 4x, 5x, and 3 are terms of the expression. X and y are the letter numbers, and the number 4 and 5 are the coefficient of x and y, and 3 is a constant. From now onwards, we will use a widely used alternate word for letter numbers variable. Thus, in the expression 4x plus 5y plus 3, we say that the variable used are x and y. So now let us understand the 4 crucial math terms from this expression. So here you can see terms, that is the individual part separated by plus sign. So our expression was, it was 4x plus 5y plus 3, right? So the individual parts separated by plus sign. Here 4x, 5y, 3 are the 3 terms. So here we have 3 terms, okay? 3 terms. And what are they? 4x, 5y and 3. Then x comma y. What do you mean by this x comma y? They are variables. They are known as variables. And in your textbook, it is given as letter number, but it is widely used by this name variable. So x, y are the variables. Next, this one is coefficient. So from this expression, you can see that along with this x, you have a number, right? That is 4. Along with the y variable, you have 5. So this number fixed number multiplied by the variable is known as coefficient. So the coefficient of x is what? 4. The coefficient of y is what? 5. So the number which is a fixed number multiplied by its variable is known as coefficient. Is it clear? Next one, from this expression, again 4x plus 5y plus 3, this 3 without a variable is known as constant. So here 3 is a constant, a fixed value that never changes, because in this expression this 3 is not going to change. So he is getting an extra free pen of 3. This is not going to change. The number of red boxes and number of white boxes may vary. Okay, so here 3 is known as a constant. I hope this part is clear. So I hope you understood the first example, how we got this expression, and in through this expression we understood what is terms, variables, coefficient, and constant, right? Now let us move on to the next example. Example 2. A rectangular garden of length L meters and width W meters has to be fenced and decorated. A wire fence is to be laid along the length costing rupees 100 per meter, and a wooden fence is to be built along the width costing rupees 80 per meter. Special seeds have to be sown throughout the garden, which will cost rupees 50 per square meter. What will be the total cost inquired? So here you can see the figure 2.2. So here we have a rectangular garden with the length L meters and width W meters. And there are three types of expenses here. The wire fencing along both lengths at rupees 100 per meter. A wooden fence along both widths at rupees 80 per meter. And sowing special seeds throughout the entire area of the garden at rupees 50 per meter square. Okay. So I hope this part is clear. You understood what is given in this question, right? So by using this information, how can we write an algebraic expression to find the total cost inquired? Cost of wire fencing along the garden length is equal to, since there are two length, 2 into L, and how much per meter? It's 100, right? So 100 per meter means we have to multiply it with 100, and this will become 200 L. Again, this rectangle garden has two width. Like in the figure, you can see it has two widths, this two sides. Okay, so we can write cost of wooden fencing along the garden width is equal to 2 into width into how much was the price? It was rupees 80 per meter, right? So here I have to multiply it with 80, and this is equal to 160 W. See here in the picture, you can see that the seeds are sown inside the garden, right? So here inside the garden, the seeds are sown. So we have to find the area of the rectangle. And what is area of the rectangle? L into breadth. So here it is L into width. Okay. So we'll write the next step. Area of garden is equal to length into width, which is equal to LW, and the cost of sowing seeds throughout the entire garden is equal to 50 into LW, which is equal to 50 LW. And the question is to find the total cost. Therefore, total cost is equal to rupees 200 L plus 160 W plus 50 LW. So adding all the three costs, we'll get our final algebraic expression, which is 200 L plus 160 W plus 50 LW. Here, this is our algebraic expression. Okay, and here the variables used are L and W. And if you take the terms, here what are the terms? 200 L, 160 W, and 50 LW. You have three terms, right? And variables here are L and W. So here this is a two variable expression. So in the first example and also in the second example, you can notice that there are two variables. The first one, it was x and y. In this, it is L and W. I hope you understood this. Now let us move on to the next example. Example 3. A wire of length 20 centimeter is bent in different ways to form rectangles. For example, we can have a rectangle with length 7 centimeter and width 3 centimeter. We can also have one of the length 5.5 centimeter and width 4.5 centimeter. Think of a few more ways of forming such rectangles. Can you write an expression for the area of such a rectangle? So here we have a piece of wire that is 20 centimeter long. Okay, so total wire length is equal to 20 centimeter, which means the total wire here means the perimeter. Okay, and we bend it into a rectangle. Because the wire forms the boundary, perimeter of any rectangle we make will also be 20 centimeter. Then, since the perimeter is equal to 2 into L plus width is equal to 20 centimeter, dividing by 2 tells us that length plus breadth is equal to 10 centimeter equal. Okay, for example, if length is 7 centimeter, width is 3 centimeter, that is 7 plus 3 is equal to 10. Again, if length is 5.5 centimeter, then width is 4.5 centimeter. So here 5.5 plus 4.5 is equal to 10. Now, how do we write a general expression for the area of any such rectangle? Here, let length is equal to x. Since the sum of the length and width is 10 centimeter, the width becomes, we can write the width is equal to 10 minus x centimeter. Then the area of rectangle is equal to length into width, and this is equal to x into 10 minus x, and multiplying inside the bracket gives 10x minus x square. So here this is the algebraic expression for such triangle. Now here you can see the variables used. Here the variable used is only x. So we can say this is one variable, or it can be called as univariate. And in this algebraic expression, you can see the x square. So here the highest power of x is what? 2, or the degree is 2. I hope you understood this. Now let us move on to the next topic. Note that the algebraic expression in example 1 and example 2 involves two variables, whereas the algebraic expression in example 3 involves only one variable. Okay. Expressions such as 4x, x square plus 1, 2y minus 5, 5y cube plus y square plus 2y minus 1, 3z plus 7 are algebraic expressions that involve only one variables. Those are x, y, or z. In this chapter, we will strict our discussion to algebraic expressions involving only one variable. You may have noticed that in an algebraic expression, the powers of variables also appear. For example, in the expression x square plus 5x plus 1, the highest power of x is 2. Whereas in the expression xy cube plus y square minus 8, the highest power of the variable y is 3. Further, in the expression 5y cube plus y square plus 2y minus y, the coefficient of y cube is 5. That of y square is 1, that of y is 2, and the constant term is minus 1. Such algebraic expressions involving one variable and its power are called one variable polynomials or univariate polynomials, or when the context is clear, simply polynomials. That is, univariate means having one variable. The highest power of the variable in a polynomial is called its degree. So here you understood what it means, like one variable, right? One variable, it means that in one algebraic expression you will have only one letter. If it is x, it will be only x. If it is y, only y. And if it is z, only z. There won't be any two variables. And here you can notice powers also along with, see, in this expression x square, here the highest power is 2. because here it is just x means x raised to 1. So usually 1 is not written, so it will be like x. You have to understand the power is 1 over here. So here the highest power is 2. Now taking this expression, you can see y is having the highest power 3. Here it is 2 is also there, but the highest power is 3. Now coefficient, I told you what is coefficient, right? Coefficient means the number along with the variable. So here along with the y cube, what is the coefficient? It is 5. With y square, here you can see there is no number written. So you have to write it as 1. When there is no numbers written, it is understood that it is 1. See, the coefficient of y is what? It's 2. And a number without a variable is a constant term. And here the constant term is -1. And don't forget to put negative sign along with this number. See, this number, it is negative. On the left side, you can see the sign, negative sign. So when you're writing the constant term, write that negative sign also. Otherwise, it will be wrong. You can't simply write 1. You have to include that negative sign. If this was plus, you can simply write 1. But since it is negative, you have to write -1. Okay, and any variable or an expression with the one variable is known as one variable polynomial or univariate polynomial, or it can be also called simply polynomials. And the highest power of the variable in a polynomial is called degree. So means if you are asked what is the degree of this expression, you can write it is 3. Got it? Now let us move on to the example part. See here 5y cube plus 5 square plus 2y minus 1 is a polynomial of degree 3. Now you can see degree 3 means here y raised to 3, which means here the degree is 3. Such polynomials are called cubic polynomials. So a polynomial with degree 3 is known as a cubic polynomial. Second one, x square plus 5x plus 1 is a polynomial of degree 2. Why here you can see x square. So the degree is 2. And such polynomials are called quadratic polynomial. So quadratic polynomial means the polynomial having degree 2. Okay. Then third one, 3z plus 7 is a polynomial of degree 1. See, I've told you before itself, here this variable, there is no degree or any power short, which means that this is 1. Okay, here the degree is 1. So a polynomial of degree 1 is called linear polynomials. So this expression is a linear polynomial, or this polynomial is a linear polynomial. Fourth one, the constant 8 is a polynomial of degree 0, as it can be written as 8x raised to 0, in which the power of the variable x is 0. See, this 8 is written as 8x raised to 0, and here the degree is 0. Okay, and one more thing, x raised to 0 means it is equal to 1. So here this becomes 8 into 1, that is equal to 8. So a polynomial with a degree 0 is known as constant polynomials. I hope you understood what are cubic polynomials, quadratic polynomials, linear polynomials, and constant polynomials. And with this, we have covered all the core concept for chapter 2. This concludes our introductory video for this chapter. In our upcoming videos, we'll start solving the exercise questions step by step, part by part, so you can follow along easily and practice with me. If this explanation helped clarify this concept, please hit the like button, share this video, and subscribe to my channel. And thank you for watching.